Hello guys, welcome back to Abhi Codes. Today we are diving into a really interesting problem from GeeksforGeeks, Kth smallest number in multiplication table. It's a great blend of math and binary search, and we will solve it using Java. So let's get started. So here the problem statement says, given three integers m, n, and k, consider a grade of m into n where mat I j is equal to I into j, which is one base index. The task is to return the kth smallest element in the m into n multiplication table. So here the examples have been given here. So in input, m's value has been given as 3, n's value has been given as 3, and k's value is 5, and the output is being generated is 3. How is this so? So suppose we have created a table which looks like this: 1 2 3 2 4 6 3 6 9. And suppose this is m side, this is n side. So 3 into 3 matrix of numbers have been created. Now if we sort all the values, then the result is coming as this: 1 2 2 3 3 4 6 6 9. What's the value of k? 5. That is, we need to find the fifth smallest element in the m into n multiplication table, which is none other than 3. Same goes with m is equal to 2, n is equal to 3, k is equal to 6. Where m, where so in this case the no cut. Similarly, is another example where m's value is being given as 2, n's value is 3, k is 6. Output is 6. How is this so? So we created a matrix which looks like this: 1 2 3 2 4 6. And upon sorting all the values in the ascending order, the sixth element, in fact, the sixth smallest element of the given m into n multiplication table is coming as 6. So now the question arises, what approach should be used so as to solve this question successfully and providing all the test cases without any flaw. So instead of generating and sorting the whole table, we use binary search. Here's the idea. Set low is equal to 1 and high is equal to m into n. Then we guess a number made between low and high. Then we count how many numbers in the multiplication table are less than equal to mid. If count is lesser than k, we search right, otherwise we search left. So now that we understand about approach being used in this coding question, it's time to implement the same in Java without any further delay. So voila, this coding question has been solved successfully and all the test cases have been passed without any flaw. And the code follows the time complexity and spins of complexity of big O m into log m into n and big O1 respectively. So, if you found this helpful, don't forget to like, share, and subscribe for more coding tutorials. And comment below if you want a breakdown of any specific concept. And also, don't forget to mention whether is there any other way to solve this question even in a way. So, see you in the next video. Thank you.